There are these creatures that came from off-world. These are pariahs. NASA, notable for its essential divulgences, has for sure uncovered that this new planet isn't simply enchanting, considering the reality of its size and district, but additionally taking into account the truth that it shows lights that have every last one of the stores of being phony. Are we, all things considered, uncovering insider-certified real facts that could adjust our point of view on the universe? Could this exposure at some point or another mean there is life on various planets? Go with us as we see NASA's enchanting disclosures and uncover the reality regarding these stunning lights. In 2007, NASA passed the Dawn spacecraft with a mission to look at the most enchanting objects in our close-by planetary system. Dawn was wonderfully equipped with 3 ion motors, permitting it to embark on an unprecedented journey. Dawn's trip began with a 14-month assessment of Vesta, the second-largest space rock in the belt. During this time, Dawn sent back detailed pictures and information, revealing Vesta's confounding surface and different land accounts. Following completion of its primary mission at Vesta, Dawn set out on the second and perhaps most enamoring part of its journey, a close-up assessment of the dwarf planet Ceres. Considering its ion motors, Dawn had the capability to leave Vesta's orbit and maneuver towards Ceres, an accomplishment that traditional chemical propulsion would have found challenging. These motors, given a steady, gentle push, enabled Dawn to travel large distances efficiently and enter a consistent orbit around Ceres. Originally found in 1801 by Italian cosmologist J.P. Piazzi, Ceres is the largest object in the space rock belt between Mars and Jupiter. For quite a while, it was viewed as the smallest dwarf planet in our nearby planetary system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most significant body in the space rock belt, and one of the most entrancing due to its fascinating qualities. As Dawn advanced towards Ceres, researchers eagerly anticipated the first clear photos of this peculiar world. They saw bright spots scattered across its surface, most strikingly in a tremendous pit now known as a Cater Crater. These brilliant spots ignited brief intrigue and speculation among scientists. Before Dawn's mission, the best picture we had of Ceres was a hazy, low-resolution photo taken by the Hubble Space Telescope. Scientists had sparse information on this dwarf planet, and the chance of finally getting a close view was exciting. What secrets would Ceres reveal? What new discoveries awaited? Dawn vowed to improve how we understood the development of the nearby planetary system and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny fluids instead of molten rock. But what exactly are these perplexing lights, and what do they reveal about Ceres? Might they be evidence of ongoing geological activity, or something even more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt because of its size, mass, composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a structure more like a comet, suggesting it holds many more secrets about the early solar system than we ever imagined. After 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This marked a crucial milestone in the mission, as Dawn was able to deliver humankind's first close-up views of the largest object in the asteroid belt. As Dawn moved closer, the pictures of Ceres became increasingly detailed, offering brief glimpses at a world previously shrouded in mystery. The initial pictures revealed a surface dotted with craters, typical of a long history of impacts. However, it wasn't the craters that grabbed the attention of scientists and space enthusiasts alike. Among these features were bizarre bright spots that stood out clearly against the darker, rough terrain. As the photographs continued to improve in resolution, scientists buzzed with speculation about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something much more extraordinary? Hypotheses range from mineral deposits to potential signs of cryovolcanic activity. Closer examination revealed that the brightest spot was not a single feature, but perhaps a combination of several distinct regions. This discovery only expanded the mystery. The theory that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of transporting water or briny fluids to the surface, where they quickly evaporate, leaving behind bright reflective deposits. These discoveries challenge existing ideas about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for how we understand the potential for life in our solar system. But what makes Ceres especially significant compared to other planets? Ceres is a fascinating world, often described as a cold planet with a harsh yet fragile surface. Unlike most asteroids in the belt, which are primarily made of rock and metals, Ceres stands out because of its unique composition. Its surface is a mix of water ice and hydrated minerals, including clays and carbonates, which gives it a much less dense structure compared to its neighbors. This composition suggests that Ceres contains a significant amount of water. The surface layer is rough but porous, with ice and other volatiles trapped inside. This cold characteristic is more reminiscent of a comet than a typical asteroid, indicating a history that may have involved a mixture of rocky and icy materials. Digging further beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is believed to have a differentiated interior, consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up about half of Ceres' total volume. This mantle may be a mixture of rock and salty water, surrounding a core that could be made of denser material, potentially silicates. The presence of so much water ice suggests that Ceres may have once held liquid water, especially if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and raises intriguing questions about its potential for geological activity and the role of water in its development. However, that's not all. The discovery of ammonium clays on Ceres suggests that the dwarf planet may have formed in a colder part of the solar system before migrating inward. The presence of ammonium lowers the freezing point of water, supporting the possibility of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this captivating dwarf planet, but also provide valuable clues about the processes that govern the evolution of icy bodies throughout the solar system. Cryovolcanism is a rare and somewhat vivid geological process, especially when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, expel volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the cold environments where cryovolcanoes are found. On Ceres, cryovolcanoes operate by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it quickly sublimates, progressing directly from a solid or liquid state to a gas, leaving behind bright reflective salt deposits. These salt deposits form the mysterious bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in an area referred to as Spot 5. This region has attracted significant attention due to its high reflectivity and strange hazes observed by the Dawn spacecraft. These hazes are thought to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred recently. Furthermore, Ceres has several other bright spots, each with its own unique characteristics. These spots are not confined to one region, but are spread across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the extraordinary nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges past assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, an abundance of surface features began to emerge. The surface of Ceres is marked by various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an old surface that has been subjected to numerous impacts over billions of years. Others are better preserved, with sharp rims and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is lower than initially expected, which could suggest that geological processes are renewing the planet and erasing evidence of older impacts. One theory is that Ceres' icy surface allows for a form of cryovolcanic resurfacing, where subsurface materials periodically well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world, but one that has been and may still be actively evolving. This ongoing geological activity suggests that Ceres is not a static world, but one that has been and may still be actively evolving. This idea of resurfacing challenges previous assumptions about the planet's geologic history and opens up new possibilities about its potential for life. If Ceres is still geologically active, it might have subsurface pockets of liquid water or briny solutions, which could offer a habitable environment for microbial life, similar to the conditions believed to exist under the icy moons of Jupiter and Saturn, such as Europa and Enceladus. The potential for liquid water, along with the evidence for cryovolcanism and subsurface activity, makes Ceres an intriguing candidate for astrobiological research. If life does exist on Ceres, or if it ever did, it could be microbial life, dependent on the energy provided by cryovolcanic processes or chemical reactions within the planet's subsurface. These conditions could mirror the early Earth, where life began in deep oceans, shielded from the harsh surface environment. Beyond its geological activity, Ceres' interaction with the solar wind and its potential atmosphere also contributes to its mystery. Some scientists speculate that Ceres might have once had a much thicker atmosphere, which has since dissipated over time. However, the presence of water ice on its surface and the evidence for recent outgassing events could suggest that Ceres has a transient atmosphere or a thickening process in the past, perhaps linked to its volcanic activity. Another fascinating discovery is the potential for organic molecules on Ceres. Organic molecules, which are the building blocks of life, have been detected in the spectroscopic data from the Dawn mission. These molecules could suggest that Ceres had the right chemical ingredients for life, or that it might still possess the potential to support life today. Understanding the role of organic molecules on Ceres will provide insight into how life could have originated on early Earth and whether similar processes could occur on other celestial bodies in the solar system or beyond. The Dawn spacecraft's mission to Ceres has revolutionized our understanding of this enigmatic dwarf planet. What was once thought to be a cold, lifeless rock has emerged as a dynamic world with a rich geological history and potential for ongoing activity. The bright spots, the icy surface, the possibility of subsurface water, and the discovery of organic molecules all point to the likelihood that Ceres could have played a role in the broader story of the solar system's formation, and perhaps even in the origin of life itself. As we continue to study Ceres, we will learn more about the broader processes that shape planets, moons, and asteroids in our solar system. The findings from Dawn suggest that the boundaries of what we consider habitable environments in our solar system may be far broader than we previously thought. The mysteries of Ceres raise important questions not only about our own solar system, but about the potential for life elsewhere in the universe. Could similar conditions exist on other icy worlds in distant solar systems? The exploration of Ceres is just one chapter in the ongoing quest to understand the universe and the possibilities of life beyond Earth. NASA's Dawn mission has given us a remarkable glimpse into the secrets of Ceres, one of the most intriguing worlds in the solar system. As we continue to investigate this dwarf planet and other celestial bodies, the discoveries made by Dawn will help shape our understanding of the cosmos and our place within it. With each new piece of data, we move closer to answering some of the most profound questions humanity has ever asked. How did life begin? Are we alone in the universe? And what other worlds might harbor the secrets of life as we know it?